proved by mathematical induction that the sum from r to 1 of n of 1 over r plus 1 is equal to n over n plus 1. Now, in the previous video, we did this by a more direct method. However, the proposition is the sum from r to 1 of 1 over r plus 1, writing out a few terms. So the first term will be 1 over 1 times 2. The next term will be 2 times 3. When n is 3, it will be 3 times 4. And then so on up until the last term, which will be n times n plus 1. And that's equal to n over n plus 1. Now we prove true for n is equal to 1. So on the left hand side we get 1 over 2 times 1, which gives me a half. On the right hand side, if we put 1 in here, we get 1 over 1 plus 1, which is also a half. Therefore the result is true for n is equal to 1. We now assume true for n is equal to k, so i.e. 1 over 1 times 2, 1 over 2 times 3, 1 over 3 times 4, plus 1 over k times k plus 1 is equal to k over k plus 1. And now what we do, we prove true for n is equal to k plus 1 by adding the k plus 1's term in here and here. So we get 1 over 2 times 2 plus 1 over 2 times 3, 1 over 3 times 4. If we add in the k plus 1 term, the k becomes k plus 1 and this becomes k plus 2. And then we take our sum, which is the sum of all that, and we need to add that to it. Now from the right hand side, if we just work with the right hand side, making a common denominator, we get k times k plus 2 plus 1 over k plus 1 times k plus 1. So multiplying out, we get k squared plus 2k plus 1 over k plus 1 over k plus 2. Just write that out again. If we factorise the top, we get k plus 1 over k plus 1 over k plus 1 k plus 2. Obviously the k plus 1s will cancel, and we get k plus 1 over k plus 2, which is the k plus 1th term. Okay, so if it was k over k plus 1, so if we add 1 and k plus 1, it becomes k plus 1 over k plus 2. So this is true. Therefore, the result is true for n is equal to k plus 1. The result is true for n is equal to 1. Then if it's true for n is equal to k, then it's also true for n is equal to k plus 1. Therefore, the result is true for all z belonging to positive integers by the principle of mathematical induction. So basically, if it's true for 1, then it's true for the next value, which is k plus 1. If it's true for 2, then it's true for the next value, which is 3, and then so on for all positive integers. Okay, so this has been a video to show you how to prove a series by using the principle of mathematical induction. I hope you've understood, and I thank you very much for watching.